Hello, everyone. I hope you can hear me all right. So I'm Elvina Gountouna. I'm going to be hopefully giving you a whirlwind tour of open science and fair data and why you should care. I'm hoping for us to have an interactive session. This is really a subject that can vary, that its application can vary depending on your specific circumstances. And it's always very interesting to hear people's perspectives, their own challenges with being fair with their data and their code, what open science means to them. So I'm really looking forward to doing this with you today. So I'm going to share some things. So I think Lucy has already put in the link for the Etherpad for the course in the chat.
I haven't yet. I'm about to. I just put the more housekeeping thing.
No worries. So in the Etherpad that you're about to see up here in the chat, I put in a schedules for what I'm hoping we'll get through today. And also at the very, very top, I am about to put the link for the website of the carpentry course that this is based on. So we're not going to be following that exactly, and we're not going to be going through the whole course because it's a long course meant to be delivered over a longer period of time, and also part of it is targeted fairly specifically at people working with biomedical data, and I'm not sure that this is the case here, so we'll be adapting as we go. So if everyone can put their name in the Etherpad that I hopefully you can all see, and a little bit about where they're from. They're not where they're from, where you were born, but what is your background? Where is it that you're based? What kind of data or code? What's your domain, if you'd like, and your topic? Just to get a bit of an idea of what would make sense to avoid or talk about more. So I'll start with an example, right? So I am Elvina. So I'm currently a data manager for DataLoch, which is a data safe haven for health records in southeast of Scotland. So my background is biomedical and health data science, I would say. So basically, this picture is the most typical picture you will see in every data management training course ever. And it's called data lifecycle. Don't know if any of you are familiar with it, but the whole idea of it is data shouldn't be a linear process with a beginning and a definitive end. That it's part of a cycle. Well, often it's more of a spiral than a cycle, I suppose. So you would create some data starting at the top, you would process it, analyze it. You would think about how you preserve this data, you would share it. And then that would lead to hopefully your data being reused in different ways to create new data and to start the cycle all over. All of this work takes time and effort and thinking. So people are often reluctant to put in this work and this time because it doesn't seem that important in the moment, because there's more important things. And then later on, where the time comes for them, for example, to the sharing of the data, they realize that it would have been handy to have thought this through a little bit better from the start. That's why a lot of effort is being put more recently to helping people figure this out understand how the cycle works, understand what considerations and decisions they need to be making at each step of the way. So I think part of developing these courses and part of the whole open science and fair data movement is to put this into perspective and to help people understand why this is important. So the next bit that we're going to be talking about is open science. And often, if I manage to share this. Often open science and fair data are being discussed hand in hand. And there is a reason for that. The reason being, where is my screen? Sorry, give me a second. Apologies. So thank you. My computer's being like that. Give me a second. So never mind. I'm just going to do this a different way. So as I was saying, open science and fair data often are spoken together. And the reason for that is that it is very difficult to have open science without having fair data. So, and open science is often the motivation for fair data, if you like. So what really is open science? It's not always necessarily about having everything completely accessible, although that is a common misconception. But it can really be about a few different things. For example, having your data open, having an open peer review process for publication, having open access when it comes to code, having open source, having open protocols before you even do any science that you do or any research. All of these things can be open. There are obviously different challenges associated to many of these things. It's not really straightforward always to do. And we're going to be talking about that a little bit as well. So I'm going to quickly ask you to put in the Etherpad if open science is a motivation for you personally. So I'm going to write open science is important to me. And you can put like a little plus next to the answer that you feel represents you. Makes sense. So I'm curious, some people voted yes, and some people didn't vote. I wonder if that means that they are neutral or that they just don't want to say that they don't really care about open science, which would be completely fine. Not everyone has to care about open science. Just double check, can everyone see the Etherpad and all the things I'm putting on there? Because I'm about to put an exercise there. Okay, so I have just put in an exercise in the Etherpad. Take 5 minutes and think about what consequences open science has, benefits or problems, so like good things or bad things about it. So there is a few different aspects there: open access, open data, open software, open notebooks, open peer review. So have a think about, choose one or more if you would like, and comment on what you think are the benefits or challenges associated by trying to be more open with these things. Okay, so for open access, dissemination of knowledge, shared standards within community. When it comes to naming conventions, date formats, yes. Making scientific knowledge available to everyone. These are all great points. Open data, democratization of data collecting privileges, transparency in research. There are indeed issues with privacy, IP, and things like that. Provides means for reproducibility. Also important, saving time, collaboration, reproducing research outputs, better scrutiny of research software, so better quality of software, allows collaboration, allows reusing code internally, and open peer review, allows all the community to learn directly from feedback, and better ethics. Yep, these are all very good points. However, I'm sorry, is it a constant pinging for everyone else, or is it just for me?
I can't hear anything. I can only hear you.
Okay, no worries. So these are all very good points, and I think you guys have covered a lot of the main reasons why this is important. A couple of other things to note might be that all this sharing can lead to accelerating progress, because things can happen faster because they're more widely available, more people can access it. Therefore, everyone has more chances to use things to progress their research, especially, for example, in the case of journals that may not always be accessible to everyone. When things become open access, everyone can benefit from all the research being published. Other things include faster bug fixes, and you guys already mentioned that. And another thing that I don't think anyone talked about, but could be really important, is providing access to negative results or null results. So trying things out that actually are not successful. Usually it's quite hard to share those things. So then people can try the same thing over and over because they don't know that's already been tried. And it's actually not a very good path to pursue. So these are all great points. However, it's often not the main motivators for institutions to pursue or support an agenda. So one thing that has actually been quite successful in supporting open access is an initiative known as Plan S. Let me see if I can now share things again, hopefully. And people see, yes, right, getting there. So Plan S was an initiative to make basically publications open access immediately. And that has been quite successful. And now a lot of funders support that, and a lot of journals started supporting that as well. So there are many different paths to make something available. It's still quite complicated. It's not always very easy, and financial support is still required, and it's not, again, always very straightforward to figure out what is the best way to proceed for making your research paper open access, leading to the creation of things like this journal checker tool and various flowcharts to help you figure out how to make your research openly available. However, this is still much better than the situation that we had before, where a lot of things, especially the more prestigious journals, tended to not make things open access. Another benefit that you guys also mentioned was reproducibility. That is becoming increasingly important to everyone, and really is the other major motivator for open science. If things are transparent, if things are openly available, then that means that everyone has a chance to try and reproduce science, or to try and understand the differences between different approaches and what they might actually mean. So we talked a little bit about the big picture of open science and motivators for institutions. However, the last thing I would like to ask you to do for this part of open science is to think about personal motivators for being open. So perhaps there are benefits for institutions to being open. There are benefits for journals to support and adopt these things. But for each of us, these things could be different. So I'm going to copy and paste. And the next exercise in the Etherpad. So what I would like you to do is have a look at some potential benefits that other people have proposed, and think about which are the ones that you find resonate the most with you, and which ones actually perhaps do not. So it looks there are a couple of clear winners. In motivations, the most important being saving time, and getting extra value from your own work. But also building reputation and presence in the community, and transparency for your own scientific rigor and work ethic, which is quite interesting, because I think often the same transparency can also be a barrier for people being willing to engage with the open science community and being more transparent about the processes and everything that they do to arrive at the results. So I think that's actually really great. The other motivation for open science that I think is quite interesting, that you've all put in lots of zeros next to complying with funders' policies. I suppose that is more of an institutional motivation rather than a personal motivation, but it's interesting to see here. And finally, forming community, I think, is quite important, and that is definitely a great motivator for being more involved in open science. So the final thing I would like to discuss around open science is the barriers and risks open science, because obviously we talked about, why it's great, but there are some really valid reasons why it's not always easy or even possible at all to do open science. So can you name any reasons why open science might be hard? So what I would like to do, if Lucy can perhaps help us with this, is take a couple of minutes for people to write out in the Etherpad what they think might be a challenge or barrier to doing open science, and then split us out in perhaps 2 smaller rooms so we can discuss the proposed barriers.
Gina, are you okay to make the breakout rooms? Then I can join one of the breakout rooms as well. But Elvina, do you want to open the rooms like as soon as possible and then give people some time to write, or give some people time to write first and then we'll open the breakout room?
Let's give people, say, 3 minutes to just put down some thoughts, and then we can go into breakout rooms for another like 10 minutes, and then we can have a break after that and come back.
Okay, so we have 2 breakout rooms ready.
Shall we go to breakout rooms and discuss why is open science hard? Okay, so is everyone back? Can I see some thumbs or something? All right. So we'll now talk a bit more about FAIR data, what FAIR actually means, how to be fair, what are the guidelines, what does it matter, what do we care, try to think about recognizing things that might go against being fair, and think about the steps we can take to become closer to being fair. So I suppose the first thing that's worth discussing is that being fair is more of a goal, a principle, a direction, rather than something that you can say you have completely achieved. It's a way of working and trying to approach the ideal, rather than a black and white thing. So, and it applies to many things. So usually we talk about fair data, and when people think about data, they think about perhaps lab results or measurements or things that go in a table of some sort. It can also be images, all different types of imaging, anything, not just microscopes, that people perhaps might think, and depending on what kind of work you do, it could be geospatial data, it could be protocols, it could be for people who do qualitative research with people, for example, it could be interviews, it could be videos, it could be photos, but also it includes things that we don't generally consider so much as data, like our notes, our lab notes, our comments in our code, the code itself. Obviously, in some cases, it might even be conversations that need to be kept track of and might be relevant for things. So data can be a lot of things that we don't usually think of as data. Code in some ways can be the easiest thing to deal with. In some other ways, perhaps not. So in scientific publications, there are often problems that people encounter when trying to follow things and perhaps trying to produce things or understand exactly how something was done. So there are many different ways and reasons why we might look at a publication. Often the first contact with the publication might be a very superficial skimming through the abstract to try and see what the research was about and what the gist was. But then often that's all there is to it. Most papers, I would say, in their career, people is all they do. But then for some papers, you might want to dig deeper or look closer or try and understand exactly what was done or exactly what was found. And while information might be clear enough, if you just try and understand things in a more superficial level, then when you try and get the detail, it can be really difficult to disentangle or to clarify specifically what was done. So, for example, you may not get the precise details of what parameters were used to acquire an image in a machine, for example, or even what parameters were used when running software. So often, for example, you'll see people say, "Oh, I used R and I used this package," right? But then they don't tell you how they use it. They don't tell you what parameters they use. They don't tell you the detail that you might need if you want to do the same thing, or if you do the same thing and you get something completely different and you try to understand why you're getting something completely different. Another thing that might be an obstacle is that you're reading a paper that was perhaps published 2 or 5 or even 7 years ago. It links to things being available on the lab website that may not exist anymore because that was based on a grant, and grants all come with expiry dates, as I'm sure most of you are well aware of. So things then stop being available, or perhaps data code is available on request, which you may or may not do. And if you do manage to actually find the right email address for the personal request, you may or may not get then a reply. So there are many, many things that can make completely understanding and trying to reproduce research findings extremely difficult. And this is the type of stuff that the FAIR principles are trying to improve. So, as I said, the FAIR principles are just that, they're principles. It's not a law as such. It's not something you can precisely tick off, but it's a guide that you can follow. And obviously, you always need an easy to remember and cool acronym, and FAIR is doing that quite well. So FAIR stands for Findable, Accessible, Interoperable, and Reusable. Some of these things are linked. So in my head, always kind of see them a little bit as pairs. So findable and accessible kind of go together a little bit, and interoperable and reusable as well, sort of go together a little bit as well. So what is findable? Findable essentially just means something you can literally find reasonably easily. And that goes for both humans and computers. So for something to be findable by a human, how would you make something findable by a human? You would put it somewhere that the human might reasonably think to look, for example. So you would put it perhaps in a repository that people in your field generally tend to go to look for stuff. Then the machine part is you would make it that you put it there in a way that it can be efficiently searched for using like labels and tags and search terms and things by computers to make it easy for computers to then present it in the right ways and in the right places. Then accessible goes a little bit with that, because once you have located something, then you need to be able to access it, right? And you need to be able to understand a little bit what it is you're looking at. Metadata comes in quite a lot here. Even if, for example, you don't have your data anymore, or even if the data isn't possible to make openly accessible, if it's, for example, sensitive personal data or something like that, the metadata should still be accessible. And the metadata would allow you to understand what you can access it and how to ask for the right things. Then interoperable, I often think this is a lot about data formats. For example, sharing something in a really obscure proprietary format that was only used by one manufacturer that stopped making things 5 years ago isn't really going to be very useful to anyone, because they won't be able to open it anywhere. So before we share anything, it makes sense to think about what is we're sharing, whether other people can read it and whether they'll still be able to read it 5 or even maybe 10 years from now. And that is where the most simple basic formats come in handy, like basic text files and basic comma separated files, for example, for numbers and things like that. And then the reusable part is, I think, a bit more tricky, because it's often quite hard to envision all the different ways that people might want to use your data that might have very little to do with the original purpose of their creation. And in fact, we actually probably cannot really imagine all of the ways. So what you're trying to do is provide as much documentation as possible to make it clear what is there. So it's well described and people can understand what is appropriate use for this data. So yeah, so this is stuff that I'm just talking about more specifically. Oh, one thing I didn't really mention, and I was about to really, is the concept of persistent identifier. Is everyone familiar with persistent identifiers? DOI, I think is the most common. Thumbs. People who are or not are familiar with it. Okay, so I can talk about it a little bit more. So I mentioned earlier that often you find papers or other things pointing to resources that are no longer available. So the internet isn't necessarily a permanent place. The purpose of the persistent identifier is to provide just that, to provide a permanent home for a digital resource. It usually comes with a URL, and that is meant to always point to the specific resource that you're wanting to share. And it usually depends on a service that does this job for you. The DOI, a digital object identifier, I think is the most popular one. And this is what you see here. This is often used for research papers, but also for other things. Public repositories for data often maintain an address for content in a stable form. So a permanent link, so you may also hear of that called as a permalink. So that if you share this link, you have relative confidence that it will always point to the right piece of information. In this case, probably something that you've shared, like a data set or perhaps some code. Okay, so I've spoken a lot. Now I will put something in the Etherpad for you guys to go and have a look at. And think about in this specific dataset record, if and how the FAIR principles have been met. So let's take 5 minutes and then you can make some notes. Oh, okay. So let's have a look. Findable data. Each version of the data set is given its own DOI, along with one for the data in general and one for the paper. Yeah, that's right. So one thing that can be confusing at times is when things have many versions or many different releases, and it's not always clear which version was used for a publication, which version of dataset, which release. So one of the things that DOI can help with is that each version or release of a dataset would have its own DOI, so there would be no ambiguity there. And then again, you can reference the paper separately as well. Accessibility, the data can be directly downloaded from Zenodo and also on GitHub, that's right. So all you really need is a browser. You don't need any special software or anything like that to be able to get the data. Interoperable, standard CSV formats and text formats. Yep. And also linked to other rich information about the dataset that would help you understand the context of it. And that goes for R as well, the reusability. There's a link to the methods used to collect the data, which should provide hopefully enough detail for other people wanting to reuse this data and to understand what it is that is being shared. So I'm sure if someone tried, they would be able to also find, if they started digging into this publication, perhaps they might even start finding things that are not entirely clear or is easy to reuse. But at least these authors have thought about the FAIR principles. They have tried to apply them, and they've tried to avoid the most obvious common pitfalls of sharing data to go with a publication. And this does take time and this does take effort, and it is an extra bit of work. Although I don't suppose that looking at it as extra is really the right approach. I suppose it's just a newer addition to what we should really always consider part of our normal workflow when trying to do a piece of research and share this work. So I have another exercise, which is less of an exercise and more of a discussion that I would like us to have. I'm going to put it here. So if we could again go into some smaller rooms. Okay, so I have one more thing to talk about before we have a wee break. And that relates to the distinction between FAIR and open science. I think I mentioned this at the very beginning, that often people talk about these two concepts together, and they do go indeed quite well together. but they're not actually the same thing. And while trying to follow the FAIR principles definitely makes it easier to share things and is extremely compatible with the idea of being open and transparent with our work, they are two distinct concepts. So, for example, even if you're not able to share your data at all, perhaps because it is extremely sensitive, right? You can still try to follow the FAIR principles. In some cases, this may mean that all you can really share is the metadata rather than the data itself. So one example of this could be really sensitive patient data that you can't share very easily, but you may be able to access, for example, if you go through a proper process of applying for the data, making sure, signing all the agreements that say you will follow all the restrictions required to preserve the privacy and the safety of the individuals involved, if it's patient data, for example. Another really common example would be genomics. People do try and share as much as they can. It's not always possible to share everything, or at least it's not possible to share everything openly. But you can share all your protocols, exactly how you did things in excruciating detail, if you'd like, share all the metadata, and then you can perhaps apply for access to the data set itself. So then that would be a place where you cannot be completely open, but you can still be fair, and you can still try to apply the FAIR principles as much as you can. Also, in thinking about accountability and reproducibility all the way through from the beginning of your research, always, I think, leads to better quality research. Okay, so I think we have reached the moment of a break. We can have a slightly longer break, and we can come back at like 10 minutes, sorry, it's 5 minutes past 3. I'm going to also put a quiz on the Ether pad, and you can have a look at that. And note next to it if you think that this statement is true or false. And I will see you in a bit. Okay, so F in FAIR stands for free. It doesn't. It's meant to stand for Findable. Only figures presenting results of statistics need underlying numerical data. That's also not true. Sharing numerical data as a PDF in Zenodo is fair. Nope. Because it's not so easy to get stuff out of a PDF. Sharing numerical data as an Excel file via GitHub is not fair. So why do people think that sharing numerical data as an Excel file via GitHub is not fair? I'm curious to hear opinions about this, because there's been debate about this previously. And I'm curious to hear people's thoughts. So there's a lot less of us now. Some people had to go, so you can either post something in the group chat or unmute and speak.
Right. So I didn't vote for false on that one, but I didn't choose enough. But I think maybe the reason they chose that is not fair is because, again, well, Microsoft Excel is a proprietary software. And I know, like, for example, I use R a lot, and there are libraries in R that let you read Excel files, I think, without having an Excel license or like a Microsoft Office license. Or maybe that's not the case for all formats. So just trying to generalize. So instead of using a Excel file, I think it'll be fairer to use a CSV format, for example, or a TSV, is it, like for tab separated values? So anything but a proprietary file extension. Well, at least that's my logic. Someone might have a different.
Okay. What do people think about the other part of this, which is the GitHub part? Anyone have any thoughts? Yeah, Liam.
Hello. So sorry if my mic is not working properly. Yeah, I'd consider GitHub to be like the right place to share software, but for data, it really isn't like the appropriate place to put things. It's not easy to point, just kind of your browser, I want specifically like this kind of data file. I'm not sure I explain that properly. On something Zenodo, you can browse through data sets a bit more easily and actually get information about them. Whereas on GitHub, it really is just, here's a collection of text files. And if it's something like an Excel file as well, which is it isn't like a CSV format, which it's not just like an ASCII format. There's no way to just browse it in your browser. It just says, here's a binary file. You have to download it and go out your way to convert it into something which is open or something like that in order to read it. Plus, being an Excel file, it can have formulas and things in it, so the data itself might not even be just there in a easily readable format. You need to have the right software to be able to unpack all the formulas and actually give you the end result. So there's like several barriers to actually getting at just the numbers that you want.
Yep, I actually agree with you. In the carpentry website, the answer that is written there for this is actually false, as in sharing numerical data in Excel in GitHub actually is fair. So some people seem to think that that's perhaps good enough. I quite liked the way Roberto kind of expressed the idea that perhaps doing a CSV would be fairer, and there's always degrees in which we can do things. So perhaps you can do something, but there's always something maybe better that you can do. I personally agree with both of your points. Why do Excel when you could do a CSV or a TSV? There is now in some communities a shared understanding that an Excel format is apparently an interoperable format. It is open enough in the sense that there is other bits of software that can open it, like OpenOffice and other things. But yeah, as you just described, an Excel file comes with lots of potential features that you may actually not really want, or could make your life harder, like formatting things for cells and all sorts of stuff, formulas and whatnot, which may or may not be equally interoperable in 5 years, let's say, as they are now. So I completely agree. And the other thing about GitHub is because it was created to share code and not as a place, as a stable repository for data, it doesn't really offer the same stability as a data depository would, because it was designed specifically for that purpose. But it's interesting that there's always a bit of it's not always a clear answer to this one. And I think it's a good example of how trying to be fair isn't always clear cut and isn't always black and white. And not everyone has the same views. And perhaps we don't really need to have the same views, but it's always good to have the discussions and trying always to be a bit more fair than we currently are. Okay, so the next chapter refers to intellectual property, licensing, and openness. So this is not an easy topic to discuss, and it can really depend on specifics. First of all, it really depends on where you're based. So is there anyone here who's not based in the UK or the EU? No? Okay, that's good. Because all of the content that this is based on is really kind of more tailored to the UK and Europe. Oh, Joe, you're not Mexico. Okay, no problem. So just the disclaimers that some of the things that I'm going to be talking about may not be true where you're based. Although I'm going to try and keep it pretty general. Also, there's a lot of really, there's a very heavy legal element, and I am not a legal expert, so take everything with a grain of salt or two. So what's intellectual property? Is something we create using our mind. So that's a quite wide definition, really. So it could be a work of art, it could be a story, it could be an invention, it could be many, many different things. In the domain that we usually function, usually intellectual property comes in more heavily when people work in fields where there is a strong potential for commercial application. So it could be things like, I don't know, chemical structures that can then be used for drugs or other things like that, depending on what your domain is. It may not even be applicable at all. So for example, it's also mentioned in the slide, so like a plant cannot be patented. So a computer program, which is I think something that we're more kind of interested in here, so a piece of code will not be patented. So if intellectual property is at all relevant to you, there's two things that are really important to consider. One is timeline, because often the person getting a patent for something has to prove that they were the first person to come up with this wonderful thing, whatever it was. And the second thing that is really important, which is to support really the first thing, is really good documentation of everything with dates attached, because timelines are important. So any notes should be dated, any data, everything should be well documented and dated. So, I mean, there's an opinion stated here around the relative benefits of being open versus patents and things like that. That's open as opposed to interpretation, and really depends on the specifics. However, when it comes to software, we don't really think about patents. We think about copyright and licenses can become really important here. So the idea of the copyright is it would protect your code from being essentially copied and reused for things that you do not want it to be used for, or perhaps from other people like making money from your code when you're not, and things like that. So this is where licenses come in, and this is where licenses are quite important. When it comes to data, things are a little bit different again, in the sense you cannot copyright or patent a fact. However, there's always nuances in things. So this may not be a black and white type of statement, and it may depend on, again, the specifics of your work. Licenses are useful because they allow you to express in specific terms what you believe is appropriate and what you believe is not appropriate to be done with the thing that you're sharing. And we're going to look at a couple of different types of licenses that may be of interest to you. I'm going to copy it in the pad and we can have a look and we can discuss. So I'll put in the links for 3 commonly used licenses in the Etherpad. So if you want to take 5 minutes, let's say until 3:30, to have a look through these, and then we can discuss them. Does anyone have any thoughts about the licenses? Did you have a look at the first link? That's the summary of the Creative Commons license.
I didn't. I don't. I've been using probably blindly when I develop software the MIT license, because I know like the R community tends to use that as the license by default. And looking at the first link, I think the first link is it talks about any materials in general. Whilst the MIT one, it mentions about software, but I think they're both very similar in terms of what they allow you to do, which is you can, as long as you provide a reference to the original creator of the content, you can modify it and redistribute whatever it is that you're doing. Well, with the MIT will be software. With the first license will be any materials, I think. I hope that's not wrong. So I think they're very similar in that regard, but the MIT one is more specialized towards software, whilst the CC one is just Creative Commons, like any materials in general that can be copyrighted. I don't know if that's 100% accurate, but that's what I get from looking at both links.
Yeah, I think that's more or less true. The other thing to think about perhaps is that actually the first link is the human readable summary of the license, and the license itself is the thing in the third link where it says legal code. So if you have a look at that, it is a much longer document. And my theory is that one of the reasons why the MIT license is quite popular, apart from the fact that, as you say correctly, it is specifically about software, is that the text in the link here is actually the full text of the license, as far as I know. So it is a much clearer and more straightforward thing to understand. So therefore you understand what it is that you're actually licensing people to do. Because I think often the thing with licensing things is you tend to, well, as you well know, when you kind of download kind of random bit of software from any of the big companies or even the smaller ones, it always comes with these really long things that you have to agree to in order to use it. And 99% of the time, you don't actually know what it is that you're agreeing to, right? You just know you have to click through it in order to access what's behind all the text, basically. Don't know if anyone has a different opinion on this. I think the main point really is that by providing a license under which you release your software, you are controlling what you say can or cannot be done with said software, even if what you're saying is take it and do whatever you like. You've thought about it and you have explicitly stated your preference. I think that's the point of this. Going through the step of considering it and considering what is the appropriate license, and then clearly attaching that to whatever it is you're releasing. Oh, I muted, sorry. Now I'm going to go on to talk about metadata. Can I see a show of hands, please, with honesty, if you feel you're not actually entirely too sure what metadata is and what metadata isn't? So if you're not feel super confident that you clearly know exactly what metadata is and metadata isn't, please raise your hand. I'll raise my hand now myself if I figure out how to do it. Okay, thank you for your honesty. So as someone who has been in the kind of data management and fair data and all this for a while, I have to say metadata is like one of those terms that is very difficult. I'm not 100% sure why. That is a thing. Maybe it's because the metadata covers quite a few different things. But a very simple definition is data that describes data, metadata. Like, oh, okay, well, that makes sense. That's quite simple as a concept. But then the practice of it can sometimes be a bit tricky. So what is metadata? Is the description of data, okay? It permits us to understand and interpret data. It's as important as our data. We should always attach it to pretty much everything. There are many ways to make it, depending on what it is we're doing. Some of it is produced automatically. Some of it has to be manually created. And here's an example. So this is an image. And this is an example of what some metadata attached to an image could look like. So what sort of data could we possibly want to have about this image here? So it has a name, like a file name, has an image ID, it has an owner with an orchid. It has an acquisition date, import date, presuming it's importing some sort of software, dimensions, and so on, and then some tags associated with it. So this is an example. Different disciplines often have standards associated with their specific types of data, but that's not always true, or these standards are not always very strictly defined. Furthermore, metadata also comes with a scope. For example, that was what we saw before, was metadata associated with that specific image, but then here is some metadata associated with the data set. So it has, if we go out a step, and it has slightly more general information about the protocol of the study and the data that was created. So that's lots and lots of information associated with this. So I spoke a little bit about the scope of metadata. Often you can think of it as the level of detail, or if you have the level of magnification. Let's say if you had a telescope and you could zoom out and you could see everything in the solar system, and then you'd have, metadata associated with the solar system itself, but then you could like zoom in and you would have perhaps a planet, and you would have metadata associated with that planet, and you could zoom in a little bit more, and if that planet was Earth, you could have like a single perhaps continent, and you'd have metadata associated with that, and so on, going down to an individual perhaps data point. So there's many different ways that we can approach metadata, and the different levels of information will be used perhaps by different people at different time points for different purposes. For example, administrative metadata would be useful for people managing perhaps the project or the experiment. If, for example, you're in a university and you have a research study, there usually will be some kind of code associated with the grant that is used to support the research. There will be a PI, like a principal investigator, which will be the senior scientist responsible for the whole thing. There will be dates that will be relevant, start dates, end dates. If it's data, for example, that you've gotten from somewhere else, there might be dates associated with that. For example, like when you were given the data and how long you're allowed or even required to keep the data for. That's one type of metadata. Then there's like descriptive metadata. So things that allow you to discover, identify. This is like the things we talked about, persistent identifiers and so on. Sorry. And then structural metadata, you could think of that as things associated, perhaps the protocol that was used to acquire or create a data set. And then once the dataset is on disk, how is this organized and so on. For software where things are a bit less, less data centric, this type of data again could be different, and it could be associated with the authors of the code and different releases and different versions, and what was kind of added in each version and things like that. So it depends on what it is that you're looking at. So this may be not very straightforward to do as an exercise for people who are not very familiar with a biomedical type of work. It's an example of different types of metadata.
Elvina, there's a comment or a question in the chat about structural metadata and data documentation.
So I thought about data documentation. I'm not sure exactly what you mean by data documentation, but it may not be incompatible with what I talked about. So can you explain what you mean by data documentation? So we can perhaps clarify.
So I'm not entirely sure either, but I would imagine data documentation is, for example, the like this variable means this, it is a numerical one or a categorical variable in it. Are these options to choose from? There, yeah, yes, so something like data specifications. Is that a good way to describe it as well, Inga? Maybe.
Yeah, I mean, I don't disagree. I also think that all of these things are structural metadata. So how it was created, so collection methods and things like that, but also how it is organized and structured. If there are groups, if, for example, if there are groups, or if it's this group versus that, for experimental design, or the different types of variables, what type of variable it is, what the variable means, also how things are then structured and organized on disk, because eventually most of these things end up being digital data. So I don't know if I said something that was incompatible with that. Okay, so looking at this picture that I've shared here. Does anyone have any ideas what parts of this spreadsheet could be administrative metadata?
I will say probably rows 1 through 7. Right, no, 1 through 6. Because you're giving a title like who is the funder for that research in particular, who the authors are, their contact information, and there are 2 protocols, well, 3 actually, 3 links to different protocols that relate to how the data was collected. No, it's not really yet describing the data itself. But I think that's another part should be in the descriptive, or maybe structural. I'm not sure actually if it will be descriptive or structural. Well, I know like the columns in row 8, for example, each of them will be an entry in the metadata describing the structure of each of the variables. But back to the question, rows 1 through 6, I'll say.
Other thoughts around administrative versus descriptive metadata, perhaps? What do you think could be descriptive metadata? Yeah, row 7. What about the study date range?
Administrative, maybe?
Or the authors? So, yeah, I mean, the authors of the exercise have said, as in their solution, right, that the authors, the title, and the study date range are the descriptive metadata for this example, rather than administrative. But really, I could see some of that going both ways, and I guess it depends. It can depend on the specific of where you are, who might need to access what information, and some things might be actually qualify as both. So it's not a black and white thing. Then the more detail of the data here, for example, the actual results, the conditions here in the table, they name these as structural metadata. So it's kind of more the detailed data about the data and how the data was acquired.
In this example,
Yeah.
the column names, what will be the column name then? Because I thought then that will be structural, because then they are describing, all right, I have this column for this variables for this data set. Isn't that what a structural is about? Not the actual data.
Yeah. So you mean the structural, the column names, like these ones that kind of run above the green stuff, or just all of them in general?
I just meant the columns as in the names. So row 8, the headers, column headers.
Just in general.
Yeah.
Yeah. I mean, I would consider those potentially metadata as well. So thinking, for example, if I share metadata for electronic health records where I work, so we will share the column names essentially, like the variable names, right? So I will share the variable. I will share that this data set contains these variables. So the variable will be what here is the column name. So like the header, line 8, right? So I will share that in my metadata catalog. So for me, that would be metadata. But yeah, and there's not always agreement, I think, 100% agreement on what is what. And you said, well, I think that all of this stuff really is administrative metadata, and I can kind of completely see why you would say that, but I can completely also see why the authors of this exercise distinguished this stuff in yellow as descriptive, because it is stuff that describes the data set as a whole, whereas the things in blue, like the funder and the contact, has a more clearly administrative bent. So yeah, I don't think it's like black and white or necessarily always clear what is what. And in fact, I think, yes, that is exactly also what the next slide sort of is hinting at. So what is data and what is metadata can be a matter of perspective. And so I would have thought that the variable names is metadata, but the variable names were not actually flagged as metadata at all here in this exercise. Then the type of metadata again can be debated, and even you said, well, I'm not sure if all this stuff in green is even metadata, or even perhaps it's actually just the data. And perhaps I would also agree. I would see this as a categorical variable that's just part of my dataset, for example. I wouldn't see it as a structural metadata, but obviously someone else had a different interpretation. So it's not easy. And which is why I also raised my hand when I said, who isn't entirely confident that they know exactly what data is and what data isn't, because the lines are a bit blurry, let's say. Even so, I think there's only one way you can go really wrong, and that is by not trying to have any metadata at all. So even if we don't necessarily agree on the specific interpretation, no, it's this type of metadata or that metadata, at least having it there and having the information there is important. Because if I just showed you, did I just stop sharing? I'm sorry, I'm gonna share it again. Yeah, because if I only showed you this part here, starting from line 9, and said this is data set, you will have much less information about the whole thing, and not as good of an understanding on what this thing is meant to tell you. Then if I gave you the header, line 8, you might have a slightly better idea of what it is that this thing is about, because at least you have the column names, right? So you have the variable name that gives you some information. Then if I gave you a data dictionary to go with that, with a variable description, then you would understand a little bit more about it. If I gave you then the protocols listed above, then all of a sudden you start getting a much better understanding of what this is about. And assuming that this company is a publication, if I gave you a link to the publication with the authors and all this, then you again understand more. So there are degrees, I suppose, to what you can do. However, what to include in the metadata isn't always easy to know. And if people don't have a standard way of doing so, then that can also be quite hard because there is no standardization between data sets. And it's also quite difficult then to bring them together to support the fair thing, especially for the machine findable aspect of things. You want some consistency, right? Because computers like to expect things in specific ways, and you want to be structured and you want to be consistent in how you present things, and you want to have precise category names, and each data set needs to use the exact same name so that then the computer can go and like group them all together and present them as part of a category and so on. So that prompted the idea of the minimum information standard in biosciences. However, this is only really relevant for biosciences, but there are other standards, and there is a website called Fair Sharing. Let me put a link in the chat. That you can go and explore. It has a lot of different standards, and it's not all focused on biomedicine. So it's worth having a look at that to see if there's something that relates to your specific field. Okay. It is possible that for what you do, there are no metadata standards. So what do you do then? Then you need to use common sense, basically. And the most useful piece of advice for deciding what metadata is important to include in something is to think as a consumer about your data. So think about your data as someone who just wants to take it and use it while simultaneously trying to forget everything you already know about it, which is really difficult to do. And which is why it helps to get other people to help you with this. So you create something, then you give it to someone who has no idea what it is you're giving them, and asking them if it makes any sort of sense, what they understand, what's confusing, what's missing, this type of thing. Any thoughts up to this point about metadata, or any experiences from your own fields, good or bad, to do with metadata? All right, so I'm putting a couple of more links.
Just going to share that Inga put into the chat that her experience is that metadata is often not complete. And Liam has followed up that in his field, you're lucky to even get a descriptive file name. Better metadata standards are sorely needed.
Yeah, I'm not surprised, to be honest. The metadata is really hard. For many different reasons. So it's easy enough for me to kind of, show you a spreadsheet that's of a good example and say, well, there you go, that wasn't so hard, was it? But actually it is hard. And the specific example that I showed is probably from one of the disciplines that has really thought long and hard about these things and has really done a lot of work and is perhaps slightly a bit more ahead than most other people. So generally, I think biomedical science is trying hard with standards, and some areas within biomedical science, which is obviously a really wide and general designation, have thought about it for a bit longer, are a bit more mature. There are other areas that are probably also quite good at this, but I don't know which ones they are. So I'm not saying, biomedical science is good, everyone else is bad. It's just the only area that I have some experience in. One of the links in the course here that I put just in the Etherpad, it says how to fare and about metadata, is not specific to biomedical sciences. And I think that's quite good because it can provide some ideas that are not too specific to any disciplines, really. But I think some things are the same for everyone, like independent of what your discipline is. As you say, descriptive file names is one of those things that a little bit can go a long way. So a descriptive file name rather than file 1, file 2, file 3, which we still get sometimes. A README file, even with the most basic information about data, like what kind of images they are or something like that, or even pointing to the research paper. Often you don't get these things. I think the idea of having minimal standards is great because it acknowledges the fact that metadata is hard, and that trying to do everything all at once and trying to come up with a really complete, elaborate and detailed and consistent standard when you're starting from zero is perhaps not the most productive way to do it. And to think about, okay, so what is the absolute minimum information that we need to be able to understand and reuse this data is a good place to start. So if there's nothing in your field, then that's the thing to think about. What is the absolute minimum information that I would need to understand this data enough to be able to use it? It's definitely a work in progress, and I don't think it will ever be complete. More thoughts on this specific topic? Okay, so we're gonna have a 5-minute break and then come back for the final part. Okay, so thank you for sticking through to the last part. I know sometimes this long series of online courses can be quite tiring. So I have only scheduled one last subject, but I wonder if, depending on what people think, we could squeeze in a couple of different things. So Let me show you what this is about. So this chapter is called Being Precise, which we all like in principle. What this means in this case in the context of our data and metadata is thinking about how metadata can be most useful. So, for example, it has here a quite common problem of author disambiguation. Especially if you don't have a very short name, or if perhaps there are many different ways in which your name could be presented. Some people have, one short first name and one short last name, and that's it. And they're perhaps don't have that problem so much, unless they happen to have a quite common name, and there's like quite a few authors with the same name as them. So then that becomes a different problem. So often, if you start searching for a paper that was written by someone, and then you realize that their work is quite relevant to you, so you try to find more work from this person, and then it is not quite so easy to find all the different bits of work, because in the different journals, perhaps they've been presented in different ways, or you start in neuroscience and you end up in, I don't know, physics, particle physics, because it's an author with the same name working in a completely different field, and then you realize that that was not what you were trying to do. So to combat this problem, the ORCID was created, which is a free, unique, persistent identifier for people, in this case, rather than papers or data sets. So can I please see hands for people who have one of these already? So if you don't have one of these, I'm going to put the link in the Etherpad. And you can check it out and make sure you get one of these if you are involved at all in writing scientific publications. However, people are not the only things that sometimes benefit from disambiguation. Depending on your field, it could be different things. The example posted here is biological science and has to do with the names of organisms. One of the options for dealing with ambiguity in this case is a controlled vocabulary, like the one presented here. A controlled vocabulary is pretty much any predefined list of terms. Any case in which you have to choose between a fixed list of names would qualify as a controlled vocabulary. It has some obvious benefits because it helps with being consistent. So you choose one name for the same thing always, rather than having a few different ways to describe it. And taxonomy goes one step further because it offers a hierarchy. So it's not just a flat list, but it's a hierarchy of terms. So in the example here, there are things that belong in the same family, and that is the concept that is being exemplified here by this hierarchy. To go even further, there are ontologies, which is a very formal conceptualization for a domain. And this may or may not be relevant to you because it does tend to get quite specialized. So what I thought I'd do is I thought of a couple of different things that we could have a look at instead for the final half hour or so. One option is working with files and how that can be done in a way that supports being fair. And the other option is about planning the research data lifecycle, how to plan for being fair throughout a research project. So I suppose what I can do is I can put here and you can vote if you prefer the one or the other. So I put a name for that. I'm going to put a plus next to the ones you like best. Anyone else want to vote? Okay. So planning for fair it is. I suppose that means going back to this picture of the research data lifecycle and the main idea behind that, which is that it's not a linear process and it's a continuous process. And it's something you need to think about throughout the whole duration of a research project, from the beginning, before you even create your data. Then when you have data and it's on the desk, you still need to think about it, need to make choices that will then support you later on in terms of being able to trace exactly what you've done, which will support the reproducibility aspect. For example, keeping detailed notes that would allow you to then have all the metadata that you need at the end, doing things like data management plans. Let me check, there should be a picture about that somewhere. Yeah, data management plans. It's something that most funders, at least in medicine, ask you to do, but it can be a less or more useful document depending on how you approach it. It asks you to think about questions like how you will store your data, how will you organize it, who will have access to it, how will you keep logs of what you do with it, then how you will share it with whom, what are the risks of doing so, what will it cost you, make sure you have that all accounted for. Then this is something that can be and really should be revisited throughout the project to see if it still makes sense, if it's still correct, and if it still supports what you're trying to do. So I have a question. Has anyone here ever written a data management plan or contributed to writing a data management plan for a study?
I'm supposed to be updating one at the moment for my team, which was developed a couple years ago, but since then it's been a bit outdated. So I'll be contributing to one very, very soon.
So how did you find the experience of being asked to do this task, and then you had to go and read it and consider all the steps where it's still accurate or it is not accurate? Was it a difficult task? Was it an easy task? Was it useful?
It's been I've been through the original plan, and what I realized is that some of the things that were included were very general. So what we're trying to do now with this revised version of it is to tighten it to what we are actually doing now, because the one that exists, it was during the funding stage. So that's when you're saying like all the different bits that you want to do. But now that we're actually doing those bits and preparing all the is that we want to tie our data management plan to those. If that makes sense. So like narrow it down from a slightly more general one. And it's been a great experience for me. That's the first one that I worked on.
Okay, that's interesting, and it's great to hear. And I suppose it makes sense that when you start something, you have much less information, and some things are a bit more vague because you don't actually know exactly how it's going to be until you have some data. So your first version of the plan is written when you don't necessarily have all the information to write all the details, right? But it does help you at that point make some decisions around making sure you have enough data storage, for example, for whatever it is, if it's a big data type of thing, making sure you have like the funds to get the storage and maintain it and all those things. But then, as you say, when it comes to a more advanced point in the project, some things become clear, and often some plans change as well. So what you thought you were going to do ends up not making sense when you try, then you have to change it, or some other circumstance has changed that prompts you to adapt your plan. And that is also to be expected, which then means, again, the plan changes. So I think the data management plan is meant to be a living document, and that means something that you revisit and something that is meant to change. And if it hasn't changed at all since you first written it, that's probably either you had an exceptionally good skill at writing it and guessing and anticipating all the things, or you're not actually keeping it up to date. I suppose these are the two things. Okay, so Inge says, as the steward, help researchers with writing one. Yep. So that can also be a challenge, to help other people write their data management plan, because you don't understand the research as well as they do. That's their part, I suppose. I've had to do this as well in a previous role where I was data manager in the Institute of Genetics, and people doing lots of really great research, but also at the Institute had a quite wide range of research that was done. So it was pretty much impossible for me to understand every single bit of it. And then what I realized after helping a few people with their plans was that I don't really need to understand their research to the level that they do. That's kind of their part. My part of it was to understand the bits that were what level of detail is needed, perhaps, in each section. What are the questions that they need to ask themselves, and help guide them through perhaps some of the decisions around what would be an appropriate place for storage of the data. For example, if it's really big data, they would need to access specific university resources. If it was really sensitive patient data, I would have to go to a different place, and helping, it's more of a conversation to support people through the decision tree, if you like, because it's a decision tree in certain things. So I don't know if Inge, that has been your experience as well.
Yes, that sounds familiar for me. Yeah. I also support different kind of disciplines. So it's the kind of research is really diverse. So I'm not. It's not possible to understand really the content of the research. So it's well, it's an how do you call it? It's sometimes difficult to support them because you don't know the content. So you need to ask the good questions, the right questions.
Yeah, I agree. I also find that researchers who are more willing to engage with the process of writing a good data management plan actually have a positive experience, and they find it quite useful, and they are more likely to then revisit it at a later date and check where things have changed and if there are any new decisions that need to be made. Because it really is about helping you anticipate things and helping you plan for things in the right moment as much as possible. Because sometimes it's not possible to plan 100% and recognize this. However, thinking about, for example, how will you share your data is often a common question. And you're asked this to think about that before you even have one speck of data to speak of, right? But then if you do think about it, and if you do think about perhaps repositories that would be appropriate places to share your data with people in your discipline, then, and you identify that, then it can also help you go and investigate this repository if you've never used it before and say, okay, what will it take for me to share my data here? What will they ask for? Because usually repositories will ask for certain things. They'll ask for metadata. They will ask for things to be structured in certain ways. They will ask for information, specific information. Knowing that beforehand and being prepared and perhaps keeping that in mind while you then acquire your data or collect it and start storing and processing it in different ways can help, because then you can do things from the beginning in a way that will make your life easier later. And I think that goes for everything. So that's in terms of how to plan for being fair. If from the very beginning you're thinking that you want your data to be interoperable, reproducible, and your code to be findable, accessible, and all of these things. From the beginning, you're thinking, and you have quite a forefront of your mind that everything you do, you want it to be suitable for consumption by other people, let's say. Then you work from the beginning in a way that supports that, rather than deciding at some point near the end, right before the sharing bit, let's say, that you need to convert everything and create all the content, the metadata and the information, the documentation to make that possible. So I suppose planning for FAIR essentially comes down to this, being aware of the principles from the start and trying to work following those principles all the way through as much as possible. It's never going to be perfect, and it doesn't need to be perfect. But if you're conscious of what you're trying to achieve, that's going to take you perhaps even 70 or 80% of the way there, which is 80 or 70% of the way further than you would have gotten if you weren't thinking about this at all. Does that make sense? So thinking of this as a way of working, as a way of thinking, as an approach, can be much more useful and successful than thinking of it as a goal to achieve. It's not so much a thing to achieve, but a way of doing things. So I'm curious, to ask you, after having spent an afternoon thinking about fair data or being fair and how that applies to you, do you think that you have a better understanding of what fair is about? And can you see any clear changes you may think would benefit your work specifically?
If I may go first,
Of course.
yeah, I think it's been great. It makes you think, why do we want to go through make sure that our data is fair, that the way we are doing things is we're following like, could we say, some sort of standardized procedure? Because I think that's the whole issue sometimes. Like, when you have to follow some guidance, people think of it as something being cumbersome. They are not really thinking in the longer term. So the way I see it is that, yeah, it might involve a few more steps of like when you're designing like the metadata, like when you are exporting the data formats, when you're picking a place to store the data, and all these things. But I think it pays off in the longer term in the various things that we have talked about it. Like, well, you get more people to use your data, which will give you more, will highlight your research, which will translate eventually into funding opportunities, into collaboration, into much larger impact. So I definitely take lots of those things, and we'll try to implement them in my role. So it's just thinking that, yeah, it might look like much more work at that moment, but it's something that it will pay off in the longer term. So yeah, that's my takeaway.
Well, I'm glad to hear that. The other thing is, I think that doing a little bit of work as you go through actually ends up being, it may seem like more work in the moment, but actually ends up being less work than you would have to do at the end to then be able to share things or clean things up or tidy things up in enough way to say finish and let go of a project and document well enough. I think documentation is something that is done relatively painlessly along the way, but it's really painful to do after the fact, and it's never quite as good. And essentially being fair, I think, is a lot about the documentation of things. And it's pretty much impossible to be fair if you don't document things. Any other thoughts from people? Okay. Okay, so Inge says about different kinds of data. Yeah, I think often when you think about data, we think about a quite narrow view of what data is, and we usually think about like numbers, I guess, most of us, or perhaps images. But it's really can be so much wider than that. And even if our discipline is mainly numeric, we still usually deal with a lot more types of data, and our notes and our documents and our codes and all of that fits under that. So that's always something that's good to keep in mind.
I just
So
thought something
yeah,
else.
go on.
That
Yeah.
might be relevant. I don't think it will be the case for everyone. For my particular research, like we are funded through like public money, like public funds. So I think we owe to put that extra effort into making things more accessible, and so that they could be reused. It's not that, right, I used it, I got my results, I got my publications, went to a conference, all good, but that's it. No one else can use those ideas. No one else can augment that work that I did. So I think we ought to do it, like to have funders and like again have that much larger impact than just like I used it and that's it.
Yeah, I mean, I think often when you're working on something, you tend to get quite absorbed in it. You kind of go more for like the depth approach, because you have to while you're engaged with it in that level. But then that also sometimes means that we tend to forget the bigger picture of why we're even bothering to do these things in the first place. Why we do what we do. Most of us become engaged in this type of work because we have an interest in the public good, right? And in having some sort of impact, positive impact. Then sometimes we tend to forget that. So I think working in a way that supports being more transparent and open also helps us remember that, and helps us remember that we're part of a bigger picture ourselves, and where our work fits in. So there are quite a few resources that could be useful to people. A lot of it is discipline specific, so it's kind of hard to know sometimes which one might be the best one for you. So for example, thinking about where to share data, that's quite specific to each discipline, and even within disciplines, like the more sub-disciplines, if you like, might have like their own niche places and communities where they share things. However, some things are more universal in the sense of the principles that we've been talking about really don't depend on anything specific, and probably most people working with data or code would benefit from having good culture around documentation and version control and things like that. So things are more universal, I think, and they really are the basis of trying to be fair with whatever it is that you produce. I think for code specifically, things are a bit easier in some ways because there are often less barriers to sharing, apart from what we talked about, perhaps some machine learning models and things like that to do with sensitive data or some other way. But I think in many ways there are less barriers when you purely deal in code or mostly deal in code than when you're dealing with lots and lots of data. And in some ways it can be easier to maintain a better practice. But the main thing to support all of that is community. And that can be even just within a team. And people can often be leaders in that. So if you start showing by example how well your practice serves you, then people are likely to follow because they'll understand that actually you save lots of time and stress by having some good habits of keeping documentation and having like a sensible way of structuring things, for example. Okay, so I think that's all from me. Any questions or further comments?